Hey guys, and welcome to Top Channel 101, and today we're going to be making this infection effect using Blender and simulation nodes. Other project files are going to be on my Gumroad and Patreon page. Links are in the description. I'm going to first do a quick breakdown and then we can do the step-by-step tutorial. So I downloaded the head or the face here on Sketchfab. This is by 2On. Yeah, it's a nice looking head. And got that into Blender. You can see what we have in the simulation zone is fairly simple. We just build on top of that. I really have to get better at organizing my nodes, but yeah, basically what we need is to create a vertex group for where we want our infection to start. So in this case, I selected a few vertices. I think I need to remove the simulation zone to see that. So I created a vertex group, and you can see basically that's going to be the start of the infection. So if I add another point, maybe let's start around here into the simulation, you can see that that part also gets added into the infection. The way this simulation works is that it's all built on top of a mask. And if I preview this mask, the entire simulation is built on top of this mask, which we create with just a few nodes here. I'm going to explain to you how to do that. And this mask grows from the vertex group we created. And as it expands, we distribute some instances onto that. Basically, these things, we instance them using that mask. And we also use that mask to scale them up or to make them look like they're growing like that. And after instancing that, we add some veins. I'm going to show you the process of making all these, but they're all starting from that mask and growing out like that. From there, we use the same mask to create a material for the infection that using some noise. Very simple, but you can even make it more complicated by layering different effects onto that. And then finally, we merge all of that together to get something like that. So let's jump in and get started. I have a head here. So let's start by creating the vertex group we want. So I'm going to add a vertex group, call it start. And these are going to be the points where our infection starts. So I'm going to select a few vertices there and maybe somewhere there. And I don't know, maybe somewhere there as well. Assign to that vertex group, and we can go to geometry node and start setting up the geometry nodes. So new geometry nodes, we can start with the simulation zone and bring back the material using a set material, our material back, bring the shader editor back here. Okay, so this is what we have, and what we want to do is create the mask. We can use the named attribute node, and you can see in the options, we have the start vertex group we created here. Attribute, so whatever you name it here, so we can see, call it infection start, and it should be here. So if you try to look at this, you can see the vertices we selected, basically creating a mask. So we want to grow this mask, expand it everywhere. So what we can do is first blur this node a bit, and you can see as we blur that, it kind of expands and expands and expands like that. So we can use this by just storing this blur node into a named variable. You can call it mask, and as you know, the simulation zone runs as a loop. So whatever you do here is going to be repeated every frame. To make it animated like this here, because right now if I play, nothing really happens. What we need is to add the mask on top of itself every frame. So to do that, I'm going to bring in a named attribute, call this the same name as we're storing. So mask, add it to the simulation output. That will also bring it into the simulation input. Let me just rename this mask. This value goes in and then comes back through the simulation inputs, and then it's added back to itself, and then basically continuously like that. So we need this to be added to this like that. Now if we preview this, we should have a working effect like that, and we can determine how much we are adding per frame. If you want the effect to be faster, we can multiply this maybe like that, and so the entire face will be will be added to it. So if you can speed up the effect or slow it down, so by just multiplying a value. And I'm seeing some facets here. You can either just blur that again, let's say by 4, and that should take care of that, so that the interface is we don't want the interface to be infected. So I just want a simple infection. I don't want to have the interface covered, so I'll go with something like that. But you see, the start of the infection is really, really instant. You barely see it starting. So to slow it down at the start, I'm just going to add a float curve between the blur and then the add, and just make it, slow it down a bit like that. So it starts out simple, and then grows like that. So the first thing I want to do is to kind of make the face swell as the infection propagates. You can see the face swells up, and for that I'm going to use a set position. So when you add the normal into the normal of the geometry into the offset, you can see the face swells up, or any object swells up like that. But if we add the infection mask, and I use that to multiply, so vector math to scale up the normal. So I can do something like that. You can see now it only shows up where the mask is, and basically grows with the mask. So I'm going to we need to scale this down because this mask runs every frame, so the value of the mask goes above 1. So we need to clamp that using a car ramp so that it doesn't go beyond a certain value. So I'm just going to use that instead. Should be on this here. So it scales up, but it doesn't go to infinity as we had it before, but it's too sharp. So I'm going to blur this attribute. It's too sharp in some areas because our mask is also sharp. So I'm going to blur this attribute, blur this mask again, so that we get a much smoother transition. Yeah, let's try using a float curve instead, because I feel it might give us a much smoother. Yeah, since we have the mask already, we can also use it here. So attribute mask, so we can start working with the materials. Now you can see how that looks. I think that's great. And we can basically just do a mix RGB. Just mix this with this as the factor, connect that, and now we can start adding in. You can, let me try using a texture, because that might give us more detail. Now let me try this here, down like that, and I use it here. You can see how that grows. We can use hue and saturation to just change the colors a bit here. And you can also use this mask for the roughness. So I can do another mix RGB so that this area becomes a bit more shinier, like that. And again, we can also use this to add some bump detail. I can do a mix color. Just do a mix here, and again use this mask. For the bump, we can just apply this. See, might be too strong, so just a bit like that. Now from there, we can add these. Yeah, you can look at refresh, but I do not want to subject you to search. And what I did, I gave this the same material as the head. Yeah, I want this to be around here. So this is the swelling part, face swelling. The next part is to add these here. So for those, I'm going to create another branch, distribute points on faces like that. Those are points. Now we want to instance on those points, instance on points, and this is going to be, I'm going to call it, I think it's called a bliss or something. Use that as our instance. And now you can see what we have. We just have to align the rotation, scale these down, and join this back to the original thing. So we do a join geometry here and here, and now we have those, and the position changes as this shows, which is nice. So we want to use our mask, this mask here, use that to scale these as well. So I can drag our mask into the scale, and let's see if that works. So yeah, you can see it scales up as our mask grows, but yeah, I think we need to run it through the same curve as this so that it has a maximum scale. Actually, let me just do this and map range just to limit how far this goes. So I'm going to scale this down. Yeah, so that's going to be our maximum. And we also want to randomize the scale a bit. So I'm going to use a random value so that they're all not at the same scale. So I'm going to pop that like that and just randomize things a bit. And maybe you could even use more, or we could use a noise texture, because that's going to give us a better random effect. Let me add a ramp and then a math node, but these are scaled too much, so I can just come to this value and just make it, darken it to create a nice minimum value. You can see now we get a nice range of really small points and large ones, and I like how they grow as a result of the noise, and you can change this up a bit as much as you want. So that's, I think, much better. And I want the skin to be kind of similar, so I don't like how this is too different from this. So let me go back to the shader, change this up. Instead of using this, let me just use a noise texture. This should also go to the bump. Yeah, so it looks like an infection. Another thing I did is use this mask as well in the subsurface. So the color should be the skin, and we need to, it looks like it's glowing because our mask goes above 1. So I add a ramp, that a bit. Yeah, so and now we can start working on the vines, which I think would be the final part. Let me see if I'm not forgetting anything. Yeah, I think the vines are the last part. So for those, we can create another branch. I think, where is my original geometry? I want, from the swelling, we can create another branch. But let me first drag this down. I can create another branch from the swelling, and this time we want to find the shortest path. So if I preview the swelling, this is how it looks. I can create some curves using the shortest path. So shortest path, edge, and then I think it's the edge to path. So the mesh is going in here and should produce curves. You connect the next vertex into the next vertex to find the path. I think I need to be in here. our starting point to be our mask. So I think it should be, yeah, this mask here. So if I connect that, start like that, and I use a compare node, and for the end we can use a random value so that the path ends at a random value. So I'm going to use a Boolean float. Yeah, you can see now we have something. Let me see, do I have to switch these around? You can see where we have the starting point like that, and let's see. To check this, we can use a trim curve just to see, to make sure that everything, you can see what we have. And let's first look at this. You can see the starting point. I just need to add in the other vertices. Yeah, so we have the starting points on the areas of our vertex group. Yeah, so you can see now all the points start from there and then go out like that, which is nice. We can increase the probability, basically just increasing the number of points, but they all start at the vertex point we have. For some reason, the end vertex is our starting point, and the random point, it's kind of confusing that we are using the random value at the start vertex and then our mask at the end vertex, and produces this result. But it works, so yeah, why change it? So from there, right now these veins look quite digital and very blocky. We want them to be a bit smooth, so I'm going to use set position, and bring in the position, connect it to the position, which barely changes anything. Blur that a bit, so I'm going to change this to vector, and you can see now that gives us a bit, yeah, it changes this into a more organic look. And actually this should come after the blur node so that we get some nice veins like that. Perfect. From there, we can join that to the original thing. Let me see, why is it shaky? Okay, so it's jumping like that because this mask changes. This mask changes, which changes this and changes the start position. That's why we're getting that effect, and we don't want that. So instead of using this mask, we can use, instead of using this mask that is being animated, we can use the attribute, the infection attribute directly. So let's bring that in, named attribute. So that's the infection attribute instead. So that's not animated, so everything should be stable, and yeah, better. So everything should also continue to work perfectly. Great. So if we preview this, it's no longer jumpy, and now we can convert this to a mesh, curve to mesh, and use a curve, a circle curve. Radius can be 4 as the profile. Make it taper at the end, so I'm going to use a set radius, and I'm going to use the resolution of 3 and use what is it called? Use a spline parameter, and the factor can now go into the radius like that. Need to give this a material, set material. Let's see, can I? Yeah, let me just give it the same material as everything else. Or you can create a darker material that yeah, kind of gives it a veiny look. I might also have a lot of vertices in here. So let me delete some, delete geometry splines, and I just delete them randomly using a random value. So we don't want to have too many because it seems to slow things down quite a bit. And I'm also going to add another ramp here to just taper this off at the end here. Actually, I can use a float curve. It should give me a better structure. So I want the start to also be okay. So we want this animated, and to do that, we already have this mask that is animated. So we can bring it in, and we can use this start value here with this and see if that gives us what we want. Okay, seems to work, but it's working in reverse. So we can use a float curve to reverse that. So if it should be flat, reverse that, we just have to do that. Then maybe slow it down a bit. Slow it down. Yeah. Okay, I don't want the veins to grow fast. I want these to grow fast. So I can offset the growth of the veins by just subtracting from the masks using a math node. So I'm going to subtract a value so that they come in a bit late. Perfect. That maybe slow down the movement a bit by multiplying. So is that just speeding them up? Yeah. Frame this. I want to become more organized. Vein gen. The project files are going to be on my Patreon page, my Gumroad, and my Gumroad page. All links are going to be in the description. And I'm going to add the original project as well, because I think the results are a bit different, and maybe you might want to check that out. I rendered this in cycles. Project files are going to be available on my Gumroad page. Thank you.